I have one last comment to make, and this is a thing that some students misunderstand. So remember when we were talking about vector fields and I drew in general how a vector field looks like? So a vector field is like a function or a box or a transformation that has as the input is the location in space, which can be given in x, y, z, or it could be given in rho, phi, z, etc. Yeah. So three numbers come in where the position where you are, and then a vector comes out. So that's the vector vx, vy, z, or it could be in cylindrical coordinates. So it could be v rho, v phi, vz. Yeah. And we were very careful to say that you either change the coordinates or change the basis or change both things at the same time. Okay, so you have different possibilities. Now, if you try to simplify this picture into this picture here, so we have a vector r, which is the position vector. Okay, so when you are considering your vector field, you have your so at each position you have a certain vector. Yeah, for example, this is vector v at this position, but you can also write that this position is given by vector r, your position vector, right? So you can think of this as r being your input vector and v being your output vector, and that is completely valid. This is a correct interpretation. The mistake here is to say the following. So you can start saying correct things. So you can say changing basis of the vector field corresponds to changing the basis of vector v. And this is correct. So vector v can be written in x hat, y hat basis, or it can be written in rho, e rho hat, and e phi hat basis. So changing the basis of vector v is how you changed between rectangular basis and polar basis. But the mistake that you may do now is to try to reason in an analogous way and say that changing the coordinates, which is changing this to this, changing the coordinates is equivalent to changing the basis of vector r. And this is wrong. So let me write it. Wrong statement. Changing coordinates is changing the basis of vector r. Why is this wrong? Because, so why is it wrong? Because the position vector cannot be written in polar basis or in cylindrical or in spherical basis. So let me write that clearly. Position vectors cannot be written in polar / cylindrical / spherical basis. Why not? Think about it for a second. So you can do position vector is clearly x times x hat plus y times y hat plus z times z hat, and that will give you the three numbers x, y, z that define this position. Okay, so this is correct. Now you say, okay, when I write it using these three numbers, I'm just writing the position vector as rho times e rho hat plus phi times e phi hat plus z times e z hat, and this is wrong. Okay, why is it wrong? First of all, the units don't make sense. You are adding, so the unit vectors, we could say they are unitless. Okay, so unitless vectors. Rho is a distance, it's measured in units of distance, maybe meters. phi is an angle. You cannot add a distance to an angle. It doesn't make any sense. So that's one reason. Second reason, imagine I give you the following vector. I say r equals 3 e rho hat. What is the location associated to that vector? What is it? Okay, I could tell you r equals 3x hat, and then you could tell me, okay, that's easy. You get your xy axis, you identify x hat as this, y hat is this. So 3x hat is simply the vector 1, 2, 3, this vector. This vector is 3x hat. So that is possible. But now I tell you, r equals 3 e rho hat. What is that? So how do you do it? You have to draw e rho hat and e phi hat. But you cannot draw e rho hat and e phi hat if you don't know the position. So which direction is e rho hat? Is e rho hat in this direction? Or is it in this direction? Or is it in this direction? We don't know. Why do we not know? Because e rho hat is a function of position. E rho hat and e phi hat are functions of position. So remember, e rho hat depends on which position you are. We go back to here. So remember, e rho hat is always pointing away from the origin. So once you specify the position being this, so once I give you this r hat vector, sorry, this r vector, this position vector, after I specify the position vector, you can tell me what e rho hat and e phi hat are. If I give you a different position vector, then e rho hat and e phi hat will be in a different direction. But before I have told you the position vector r, you cannot tell me what e rho hat and e phi hat are. Okay? And that's because e phi hat and e rho hat depend on the angle phi. So you cannot define a position using e rho hat and e phi hat because phi is undetermined if I don't know the position. Yeah. So that's the reason why you cannot interpret a change of coordinates as changing the basis of this vector. So let me write the two reasons. The first reason was that units don't match. And the second reason is that e rho hat and e phi hat are functions of position, so you cannot use it. If you have not specified a position vector, you cannot use e rho hat to specify a position vector. Okay? So please don't be confused by this. I think it's relatively simple. So changing the coordinates just means that instead of specifying x, y, z, you specify rho, phi, z. Okay? That means changing the coordinates. It's not about changing the unit vectors, changing the basis of the position vector r. Okay? So I hope that was clear. And with this, we finish the chapter on coordinate systems. Thank you very much. Remember that you have lots and lots of practice problems of changing bases and changing coordinates of different fields in the PDF notes. See you in the next chapter.